Yes, yes, sir. Yes, sir.
Hello, Shraddha.
Hello, sir. Hello.
Hello.
Hello. Hello, sir.
माझा आवाज येतो का?
Yes, sir.
माझा आवाज येतो?
येतोय.
Shraddha, am I audible?
Yes, sir. You're audible, sir.
Okay, so sir is joined. Just check it. Abhyankar sir is joined.
No, sir. Not yet. Not yet, sir.
Not yet, na?
No, sir.
Let us. I should call him.
Yes, sir.
Wait. I will call him.
तुमचं म्यूट आहे का चेक करा.
Hello, Shraddha.
Yes, ma'am.
Am I audible?
Yes, ma'am.
श्रद्धा मला तुझा आवाज येत नाही पण. Shraddha, am I audible?
Hello.
Yes.
Yes, ma'am. You're audible, ma'am. Hello, Pranav, sir.
Yes, ma'am. Am I audible?
Yes, sir. Just turn on the recording.
Okay.
Hello, Shraddha madam.
Yes, sir.
Hello, Shraddha.
Yes, yes, sir. Yes, sir.
Sir is going to join now.
Okay, sir. Okay.
मला काना लावा लागतो. आवाज येतो काय करू? तीन डॉट आहेत ना, त्याला क्लिक करा. तीन डॉट आहेत त्याच्यात ऑप्शन आहे. ऑडिओ ओनली मोड का? हां, करा ना ऑडिओ. ठीक आहे, ऑडिओ. तुम्हाला ते हे दिसणार नाही.
Hello, Shraddha.
स्पीकरवर सर.
Hello.
स्पीकर माईक. स्विच स्पीकर माईक. काय ते पहिलं ऑप्शन. कशा?
Hello. Hello, Shraddha.
Yes, ma'am. You're audible, ma'am.
Yeah, but it's some problem from my side. I'll just try.
I think sir is joined.
Good afternoon.
Yes. Welcome, sir. Kulkarni
Thank you,
madam,
sir.
can we start? Please start. Hello, sir. One more program is going parallelly. That is one academic council is there with in our college. So few senior faculty members are busy in there.
Okay.
Huh? They will join at 2:30, sir. Come back. Kulkarni madam, please start.
Yeah. Hello, Shraddha. Hello, sir.
Please start.
Okay. Shraddha, am I audible now? Jadhav, sir, shall we start?
Yes, madam. Yes. Please start.
Okay, sir. Okay, sir. Good afternoon to one and all. A warm welcome to day 12 of AICT sponsored 2 weeks. Just 2-week online faculty development program on artificial intelligence and its applications in biomedical engineering. I, Mrs. Vaishali Kulkarni, would like to welcome our today's speaker, Dr. Aditya Abhyankar, sir. So it's my great privilege to introduce today's speaker, Dr. Aditya Abhyankar, sir. Sir is currently working as Dean, Faculty of Technology and Professor in Department of Technology of Savitribai Phule Pune University. Sir is associated as an adjunct professor with COEP Pune as Research Associate with Clarkson University, New York, USA, and on advisory committee and BOS of many national and international universities. Sir has received the MS and PhD degrees from Clarkson University, USA in 2003 and 2006 respectively. MA degree in Sanskrit and philosophy from Tilak Maharashtra Vidyapith Pune. Sir has also won number of national and state awards. To name a few: IEI Scientist of the Year 2011 award, Sir C.V. Raman 2015 award at the hands of Honorable Chief Minister of Maharashtra. Dr. Abhyankar sir holds 8 US patents, 14 Indian patents, 7 disclosures, 8 technology transfers, 5 US copyrights to his credits. Sir has been involved in number of funded research projects and consultancy activities. His research has attracted funds from international agencies like IUCRC and TFRC. He has generated research funding of 2.5 million USD and has created state-of-art infrastructure in the field of pattern recognition. He provides consultancy to a number of reputed industries like Biometrics, LLC, USA, Vision and D, Canada, Optra System, India, By Design, Bangalore, India, etc. He is also the director of Aditya Softech Private Limited, which works in creating intelligent frameworks for pattern recognition based solutions. Sir has been closely associated with Aadhaar project and has contributed significantly in finalizing the norms and standards to be adopted across the country. Sir is the director of 2 startups, one in India and the other in USA. Dr. Abhyankar sir has generated funding under RUSA to form Special Purpose Vehicle Section 8 company at SPPU to promote and incubate business propositions into tangible forms to promote and nurture innovative research culture. We are very honorable to have you over here, sir. So may I now request Dr. Abhyankar sir to start over his session. Over to you, sir.
Thank you very much. I would request the organizers to please confirm that I am audible and I am visible, both.
Yes, sir.
You're audible, sir.
Wonderful. And I'm going to share my presentation. So if you can also confirm that you can see my presentation, would really appreciate that.
Yes, sir.
Is it visible?
Yes, sir, it's visible.
Great. So let me begin by first of all thanking and congratulating the organizers for creating such a wonderful platform and making me part of this very august gathering. I truly appreciate it. And I also understand that this is the last presentation, and after this presentation, we are going to have the valedictory program. So I'm very sure that the participants have had enough of many interesting algorithms and setups and so on and so forth. What I intend to really bring out in this particular session is a slightly different concept. And I'm going to first of all share with you a very interesting topic my group has been working on, which is 3D reconstruction. And I'm going to share with you a few demonstrations. However, there is one very important point, and if we miss that point, then we may end up missing something very, very important, which is, in my opinion, very significant for carrying out good quality research in machine learning and artificial intelligence. And that is something that I intend to bring out in this particular session. I would request one of the organizers to let me know if there is any interruption in the connection, or if at all the presentation is not visible, and so on and so forth, so that I'll be able to take the corrective measures from my end.
Okay, sir. Sure.
Wonderful. So let's get started. The talk of this particular presentation is towards building intelligent paradigms for biomedical engineering with emphasis on 3D reconstruction. And my collaborator in this effort is Dr. Kulbir Singh from Thapar University. We all understand that 2D to 3D reconstruction is a very interesting problem. The tile of my image that you are seeing right now is 3D to 2D. However, you can clearly understand that from the camera, I am closer compared to a cupboard which is behind me. And that's why, although the 3D information is projected in 2D plane, so to say, still the depth information is intact. And the problem is, can we use that depth information in order to reconstruct 3D from 2D? When we don't have enough about what is the exact depth, by virtue of looking at the different paradigms across resolutions with varying angle, can we form consensus towards building 3D? So that is the research problem in this effort. And to answer this particular question, we typically have two very systematic conventional methods which are well reported in the literature. And these two methods are, the first one is what is known to us as homography, which is based on the estimation when you don't have the complete information with you. And the second one is voxel based reconstruction method, when you have the complete data, complete information with you. Then voxel is volumetric pixel, and then you can keep on adding the layers in order to be able to generate the volume by the end of it. The boundaries are protected and the boundaries are well identified by the energy mappings and the constraints. So that is the typical concept behind voxel based reconstruction. And typically we give an example that a referral system that you will typically see in a tennis match is voxel based reconstruction method, because you have the complete data. What trajectory the ball traveled, where it hit ground, and then where did it go after that. So we have complete data with us, and we typically use voxel based reconstruction. As against that, the referral systems that we use in cricket, for example, for LBW decisions, it is using estimation, because we want to figure out how the ball would have traversed in absence of the pad and whether it would have hit the stumps or not. So that's where we have to use estimation. And typically the homography matrix, the H matrix, which is derived from the fundamental matrix, is extremely handy in sorting such kind of problems. It's a very bad time to give an example in cricket, because probably many of you must have seen that today morning we were bowled out for 36 in our second innings in a test match against Australia, and a very poor showing by our batsmen. But this is just to make you understand that these are the two typical conventional approaches that we have been making use of. And we went ahead and we thought that can we combine these two? Is it possible to bring the best out of the both worlds and come up with a hybrid system that combines homography with voxel based methods? And that is what I'm going to very quickly run you through. And our proposal is a combination. So it makes use of hybrid mixture model for the 3D reconstruction. And that's why we call this approach as hybrid approach. The concept behind remains the same. We have to map the apparent focal length with the actual focal length. So the concept is not different, but the way this aim is achieved is a beautiful combination of these two conventional mechanisms that we have been making use of for at least couple of decades. This is the reconstruction pipeline, so to say. And we know that the same scene can be captured using multiple cameras, and we use perspective transformation, wherein lens plays a very important role. And because of the lens, the depth of the information is preserved. And then the critical part is conversion of true focal length to apparent focal length. And at the time of doing the 3D reconstruction, the apparent focal length should be brought back to the actual focal length or true focal length. So 3D to 2D is moving from true focal length to apparent focal length, and 2D to 3D is moving from apparent focal length to actual focal length. However, if we really want to understand what exactly is going on and how do we achieve this, then it's extremely important for us to understand three very important concepts. And the first concept is how we can calibrate the parameters of camera. And unless and until we have a mechanism to calibrate our camera setup, we may not be able to come up with the fundamental matrix, and then the actual adjustment of the focal length, and then the estimation of the depth if we don't have that information with us. A combination of these three eventually would lead us to giving a complete 3D reconstructed model. And the one important part in this is FOV, which is field of vision. And we understand that we all have approximately 120 degrees of field of vision, and we will restrict our understanding of 3D reconstruction only to that without going beyond the realms of that. We also understand the formula for converting the apparent focal length into the actual focal length, and it emerges out of the crop factor, which is function of the diagonal of sensor. So depending upon what lens you are using and what is the field of vision, it's quite simple to calculate the crop factor. It's a well-known math. And then the question is, if the math is so straightforward, then what is it that is really, really challenging when it comes to 3D reconstruction? Now, it may appear that this is the only crux of the matter as far as the 3D reconstruction is concerned, but that is not the case. Like I said, FOV, field of vision, is well known, well understood, and that will eventually give us the crop factor that will help us figure out FLM, or we can physically measure the diagonal of the sensor, the lens. What is really important, what is really critical, is to estimate the depth. And unless and until we know how to estimate the depth, we may not be able to recreate back the 3D. And that's why depth estimation plays the most crucial, most vital role. And we typically make use of a different kind of geometry. It's called as epipolar geometry. And the whole process is based on collineation. So I probably will not spend more time on this because this is a well-known theory. If you have one single point, and if you're looking at the same point from two different, using two different cameras or two different lenses, uh, and we human beings, we have two eyes. So there is stereo vision, and that's why we understand the depth. We all know this. And you can then come up with the H matrix. So it's very trivial. And the formula and the maths is also given in many of the books. However, what is crucial is to design a hybrid mixture model, because there'll be some parts which will be completely missed. We may not have access to all the data pointers. And when you don't have the complete data, the complete info with you, how do you go about estimating it using a hybrid mixture model? So this is the crux of the work that I'm going to quickly present. The methodology is again straightforward. First is camera calibration for extrinsic and intrinsic parameters, then calculation of H, calculation of the actual volume using voxels, and then combining these two to create the real depth parameters. So that is the methodology that we propose. Now let's look at the conventional methods first. And for conventional methods, the experimental setup is quite straightforward. You have the object in between, and then you can create the FOV field of vision and keep on moving the camera throughout the periphery of FOV and capture the object with some angular resolution, 10 degrees, 15 degrees, 20 degrees, depending upon how much you are ready to invest in your experimental setup and data collection. And once you achieve that, then it's not very difficult to create the depth map. For example, this was my office a few years back, and this is how it used to look. And if you can quickly create that backlash, then it's possible to create the depth map from the basic block matching algorithm, which is the most fundamental algorithm. However, what we are trying to say is this is not enough. And using the depth match, if you can reconstruct the original scene, then how would it look? It does not look very good. And that's why we need to combine these two techniques. I will give you a quick demonstration. And so I'm going to share another screen. Just give me a minute here. Is my screen visible? Can someone please confirm this?
Yes, sir.
Yes, sir. Yeah, now it's not visible.
Share another window. Is this visible?
Yes, sir.
So the conventional setup, and you will realize that in conventional systems, if you have a typical 3D reconstruction issues, you capture the same object with multiple angles, create those. So these are the total number of captures. You can clearly see that these silhouettes can be then calculated. This looks like this. So in setup, you have object right at the center, and the camera moves all 360 degrees with some angular resolution. In this case, it was 10 degrees, and that's why we were able to capture 36 different silhouettes. And then you can do the calibration for the first axis. And this is result after carving using just one single perspective. That does not give us 3D. The moment you bring in X, Y, and Z, all three, then this object definitely becomes a 3D. However, what is missing in this object is the color, texture, and size. So although this particular object is a 3D object, and you can clearly understand and sense that this is 3D, it lacks the correct texture and color and synthesis. And that's why you can bring those parameters in. Again, that would emerge out of F matrix, and now the 3D object. And you will realize that although the projection happens at a lower resolution, it is only getting displayed at 25% because the GPU is not enabled. You can still clearly see that this 3D object is not up to the mark. So we definitely need something better. Okay, and what better do we need? Let's try and figure that out. I hope the demo was visible and you are able to see that the conventional system will not give us what is really desired. And when it comes to medical imaging, was the demo visible? Could you see the demo?
Yes, sir. Yes, sir.
Okay, thank you. And when it medical images, for example, X-ray CT or MRI or PET or ultrasound, you will appreciate the fact that many of these images are X-ray images. They are see-through images. And mapping the actual focal length with the apparent focal length is even more challenging. That's because the opacity is compromised. And that's why the matching becomes more challenging, more difficult. So these are the typical imaging modalities that we make use of. Now the issue is with CT scans, they are more accurate. However, the exposure is more. The patients, they want lesser exposure. So if they go for MRI imaging, then we understand that the exposure is less. However, the accuracy is also less. Plus, they are more expensive. And both the modalities need the sleeping position of the patient. So the point is every style of capturing has its own merits and demerits. And that's why we being the biomedical engineers, we have to deal with any and every kind of imaging. And so we cannot say that we don't want to deal with opaque or semi-opaque or occluded or semi-occluded kind of imaging. We should be ready to deal with any and every kind of imaging towards converting the pointers into 3D pointers. And what we want to achieve is the hybrid combination of these conventions. That's what we eventually want to achieve. So the data sets we have worked on, particularly for demonstrating this effectiveness, is femur and hip, scoliosis, and mandible. And I'm going to run quick demos of these three data sets. This data was collected at MMC Clinical Research Facility, Maine, USA. The flow diagram of what we have done is pretty straightforward. So let me quickly run you through that. The biplanar image slices are first of all enhanced, and we make use of in-band enhancement using the multi-rate kernels. So typically we have used DB16 for our purpose, but these are multi-rate enhancements. So the enhancement happens in subbands. The advantage is that you can map this space to lower dimensional data space, number one. Second, you're dealing with only relevant data. And third, even if the thresholding goes wrong, it goes wrong only for that subband. So the effect is not seen on the rest of the subband. So these are the three serious advantages. And then we do the statistical mapping of the information. If it is less than threshold, then we have to do 3 levels of statistical remapping, because the statistics, they emerge out of 3 different data pointers. The first one is the image informatics set. The second one emerges out of the epipolar geometry correction. And the third one is through the segmentation. And once the remapping is done, which is done in a linear combination, and someone might ask why this is linear combination. This is again for a very simple reason, that we have checked at every instance the statistical data independence while moving from epipolar correction to segmentation, for example. So since all these data sets or data pointers are statistically independent, we can come up with a linear combination of any 2 of these or all 3 of them, and so on and so forth. And once this is done, then once again, this condition is checked. And if it is not met, then we go through this process again. And once this condition is met, then the final rendering typically happens. The advantage of this is threefold. First, the enhancement is very pointed. And since in medical images, there are different elements, the bones would requirement different thresholds for epithelials, for example. And that's why the enhancement happens in a pointed manner. And these pointers can be shifted then to adapt them to specific kind of specific set of imaginary that we want to enhance and come up with in 3D reconstructed models. The second advantage is we have to deal with both the extrinsic and intrinsic parameters. The intrinsic parameters, they're a function of camera, but the extrinsic parameters, they are to be mapped and nullified so that there is invariance as well as scale, translation, and rotation is concerned. So you can come up with matrices which are both Hamiltonian and unitary, and that will serve your purpose. And third, the nonlinear optimization process then gets converted into piecewise linear optimization process. So this is the biggest challenge in calibration or self-calibration. And that's why these 3 advantages are extremely crucial. In the interest of time, I will directly jump to the equation. So the equation that we make use of for solving the manifold reconstruction weight correction is this. And as you can clearly see, this is very much similar to the radial basis functions. So you have the centroids mapped, and then you also have the weighted addition of the inputs, and then you take the squared norm, the squared difference norm of these two in order to be able to calculate the error. Then you have to keep reducing that error so that it falls below the threshold value. This is extremely important, and I'm going to talk this. That's the point that I intend to actually bring out. So the biggest question is, what guarantees the convergence? So we all know that error is a function of weights, and by virtue of changing these weights, we hope that error will fall below threshold. So the error, which is function of W, should fall below some threshold value. So this is the condition that we want to achieve. The question is, what guarantees this convergence? The question is how you can ensure that this, by virtue of changing these weights, you can definitely make error move in the direction which is opposite to the gradient, and then eventually it will fall below the threshold that has been pre-decided. So that is the question that comes in mind of many researchers. And that is something that I would like to deliberate on. But before that, I will quickly give you a demo of what happens when we follow this particular path. This is the priority information usage for doing the final error correction. And we know that the 3D shape is projected on the image space using those calibration parameters. That's what we have already discussed. These are pre-calibrated, pre-calculated calibration parameters, which are already calculated. But the biggest question is how you make sure that the sign distance is going to make sure that the boundaries will not cross the surfaces, because it's an evolving process. And the answer of this question is very, very simple again. It happens through segmentation correction. So image informatics will make sure that the starting point is correct. The epipolar geometry constraints will make sure that the boundaries are well defined. When you move beyond that boundary, the energies will be negative, energies will be reversed. And the segmentation correction is the actual process using which you can then keep on moving in the outer direction. Oh, by the way, these three are required to be kept as probabilities. Only then this whole effort becomes non-parametric, so to say. And that's why a combination of W1 plus W2 plus W3 should match to 1 or unity. It's extremely important. Only then these are the priors, these are the probables. And then the key points in the 3D sense are obtained. The distance map is calculated. Again, this is theory. So this is not our contribution. This is straightforward. This is also straightforward, but our contribution is in selecting this particular kernel. And how do we go about selecting a kernel? So that's a different ball game altogether. And I deliver a different lecture on this topic, how to select your kernel for a particular type of application or style of algorithm. But what we have used over here is again DB16. So DB16 is Dobash 16. It has got 8 filter coefficients and 8 minus 1, 7 different scales of operations. And that's why DB16 works for most of the cases. However, for us, what was crucial was to reach out to that norm calculation. And as per our calculation, probably the derivative of the order of 5 was required. And in DB16, 8 minus 1, you can go up to 7th order derivative. And that's why it was good enough for us to achieve this. Now, this is how you achieve the epipolar line, so to say. The landmark correspondences between the biplanar images are moved. So if the planes are straight like this, then achieving this is much simpler. However, we know that it is collinear. So you have to keep moving them so that you form the entire semicircle and then keep mapping those points on the semicircle. Once that happens, then epipolar depth calculation is carried out with 3D landmark locations. And this is the formula for that. The most crucial part in this is calculation of this matrix, which is what is known to us as F matrix or fundamental matrix. And once fundamental matrix is calculated in real time or close to real time, then the rest of the calculations are much simpler. Now I will quickly run you through few of the 3D reconstructed pointers. Is this visible? Can someone please confirm?
Not yet, sir.
Is it visible?
Yes, sir.
Yeah, so these are the slices. And typically radiologists, they are exposed to such kind of slices. And believe me, it's very difficult to take decisions. And radiologists, they are experts and they work fab. However, it does not give them complete clarity. And that's many times it's essential to help them and create these 3D models for them so that they'll be able to make more sense out of these 3D models. And how do we go about doing that? That is the question that we want to address over here.
Your video is not visible. Could you please turn off to save the bandwidth?
So that video will
So you're not audible. So you're still not audible.
can you stress?
So could you please turn off your video so that your audio would be clear? You're not audible yet.
Am I audible now? I have turned off the video.
Yes, sir, you're audible now, clearly.
And so you please let me know if my video is visible or not. Is it
Yes, sir, it is visible now. The screen is visible.
right?
Yes, sir, clearly.
So these slices exposed to. Can someone what this object is? This and you can clearly the scoliosis, mentals, they can be very clearly brought out, and the radiologists can take decisions based on which the doctors they'll be able to handle the patients much better. One serious advantage of this is this is what we have been doing with companies based out of Mumbai. They are 3D printing these objects. This is another case of 3D printed object, and you can see the clarity. The resolution is close to 0.5 micron, and this was a foreign body that they wanted to inject. So this is the 4, and they wanted to inject this so they can print such parts and they can practice before they actually complete their surgery. So this is one serious advantage, that such parts then can be 3D printed. This is another part that we have very carefully segmented and 3D reconstructed. It was printed a couple of months back in Mumbai. This was used in actual surgery by doctors at Apollo Hospital. And demo, and then I will switch to what I want to tell you. So this is where you can clearly see power of enhancement. These are the slices. You see the angle of the same info. once onset, for every single subband, the clarity is phenomenal. And you can clearly differentiate between bones and tissues, for example, between tissues and veins, for example. And this is extremely important before you segment the information out and then 3D reconstruct the info. Now the more you reconstruct the 3D part, the surgeons are interested in applying various different filters. So this is the 3D reconstructed part that you can see over here. And different filters. For example, this is G type of bone filter, wherein it only emphasizes on the bone structure. You want to essentially look at the bones. So such filters are extremely useful for surgeons because eventually they are going to operate. And if this can be ported to virtual reality setup, and we have actually done this for Apollo Hospital, then they virtually practice their surgeries before taking the patients on the bed. This is bones added with epithelials. This is bones, epithelials, and M tissues. The M tissues, however, all the veins are removed. That's why you see that red color. In M, as well as the tissues mapped and overlaid over bones. This is only the C-section bones. This is section bones. This is filter. This is latex filter. RBM filter. It doesn't work here. You can clearly see RBM gives very bad results. It's only to emphasize on the tissues without bones. And so on and so forth. The point is you can make a good combination of these and provide these details to the surgeons so that they'll be able to achieve what they want to achieve. However, the crux of the matter is slightly different, and the matter is something that I intend to bring out now. And I'm going to share one more presentation. So please let me know if you can see that.
Yes, sir, it is visible.
Okay. So see, we are in an era of deep learning. We typically also know how deep learning works and functions. And the most interesting part when it comes to deep learning is you don't really have to worry about feature selection. You work on which classifier would work best for this particular application. So DeepNet is a holistic process. It does everything for you. It figures out the features, it figures out which classifier works well for you, and so on and so forth. And that's why the question that remains is, if that is the case, then why for few of the mundane tasks, the DeepNet does not converge? Like, for example, when it comes to figuring out the difference between cars and trucks and bicycles, a study was carried out in 2016, and it was shown that the DeepNet does not really converge and give us good results. So the accuracy is quite limited over there. See, creating a deep net is not a challenge anymore. So first well-known, well-documented deep net was reported in 2012, what is known to us as AlexNet. And after that, there are so many variants. If you are good in Python coding, for example, you can write a 7 to 8 lines of code and create a deep net. So creating a deep net is not a challenge, or coding is no more a challenge. What is really important and what is really interesting is to figure out what will guarantee the convergence. And I'm going to skip few slides. This is the artificial model that we are aware of. These are the inputs, these are the weights, the bias. You add everything up together, pass it on to the activation function. The activation function produces the output. And we typically know that the Hebbian concept is based on the dot product between input and output. And it works well. It works well not only heuristically, but it also works well analytically. And the analytical reason behind that is very interesting for us to understand. For example, if you look at this particular very interesting example, this is this is not XOR, this is AND gate, and both the inputs x1 and x2 are high, the target should be high. For every other combination, it should be -1 or low. And then we calculate delta W1, which is x1 times t, delta W2, which is x2 times t, dot product, and delta of b is exactly same as t. And then we add that in the old values. So we make these calculations, calculate and then add them in the old values to generate new values. And this can be done for all the exemplars, and then we get the final answer. And heuristically, it works. We know that this works. However, the question is why at all this works. And now if we write down the equation is x1 w1 plus x2 w2 plus bias is equal to 0. And these are the values of w1, w2 and bias. And if I plug that in, then I get 2 times x1 plus 2 times x2 plus, sorry, is equal to 0. Let me remove this. It should be is equal to 0. Let's get rid of these 2's, and then we are left with x2 is equal to minus of x1 plus 1. So what kind of line is this? This is a line wherein the slope is -1 and y-intercept is +1. And it does the job for us, because if you look at what kind of problem we are trying to solve, see, the line is slope of -1 and y-intercept of +1. And so y-intercept of +1 and slope m is equal to -1 over here. Classification. So to the of this line, we have this +1. And to the lower side of this line, we have all the -1. So it also does the classification. So it gives us the regression analytics. We are aware of this. The biggest question is, what guarantees the convergence? Can this solution be unique? Guarantees the solution to converge? And then, though it converges, what guarantees that the solution is optimum? If there are a bunch of solutions, then what guarantees the optimality of the solution? That is the question. And I need another 5 to 7 minutes. Organizers, is that okay? Can I take another 7, 8 odd minutes to converge?
Yes, sir.
So to answer these questions, and we understand that there are problems which are linearly not separable, which are obviously not solvable using one single layer of neurons. However, for linearly separable problems, can we come up with a strategy that guarantees convergence? And this is true for deep nets, because ultimately perceptron and backpropagation, when it matures, it becomes deep net. It's no different. We all understand that. And this is the algorithm perceptron learning rate. You have a very interesting activation function, which typically looks like this. Theta or plus theta. And this is in minus theta and plus theta, which leads us to support vectors. And then you are checking this condition if y is equal to t or not. this gives an opportunity to seek convergence. And the question is why? For example, if I keep alpha to be equal to 1, the learning rate highest, then this becomes xi times t. Because alpha is 1, this becomes t. And so now this is exactly same as Hebbian. So then what differentiates perceptron and Hebbian is checking this particular condition, if y is equal to t or not. And the question is, so sure, that will make the entire algorithm sensible towards whether my algorithm moves my weights in the correct direction or not. But is that enough? Is that going to really give me the complete convergence? And the answer of this question is yes, it does. But the next question is how? So how it guarantees convergence? So what we are seeking in convergence is infinite number of iterations, infinite number of loops. There should be some W star that will give me correct XP into W star. So they will give me correct target values for all the exemplars, for all the X values. Will I be able to achieve this? And what we have seen is earlier in perceptron, we have realized that x of 1, for example, is equal to x of 0 plus w of 0. Similarly, x of 2 will be x of 1 plus w of 1. X of 1 is this. So I can write down and say x of 2 is going to be equal to x of 0 plus w of 0 plus w of 1, and this will continue. And so we can clearly see a pattern, and we can say that x of k is equal to we clearly see that x of k is going to be equal to x of 0 plus w of k minus 1. Now focus on this, and if you multiply this with this w star, what do we get? We have x of times w. So this is dot product, and this whole thing w star, multiplying this with w star. So we can plus w star into w of 0 plus w of 1 plus going all the way to w of k minus 1. These, and let you will not get these k such value. So k times w. So I can write down there are k such terms, and then if small m is the minimum of the dot product between x and w, we can definitely look at k such minimum term. So this is going to be equal to plus, so x of k times w star is equal to this, x0 plus w star plus m times k. I hope this is clear. When it matures in a mathematical formula, so k w star will be greater than or equal to w0 plus w star plus k of m. Now this greater than or equal to sign emerges out of the that m is the minimum of this dot product, and it makes a lot of sense. Now using Cauchy-Schwartz inequality, if I bring this w star on the right hand side, because this goes away because W of 0 is 0. So let's say we initialize our weights with 0 values. So this if W0 goes away, this W0 also goes away. And then we're not by the way, there is this less than or equal to sign over here. We are not interested in calculating W of k. We are interested in making sure that k remains finite. So what I have on the left hand side is k square m square upon norm W star squared norm, which should be less than or equal to this, that is k into capital M. Capital M is the max of the squared input. 1k goes and the square goes away, and that essentially means that k is less than or equal to capital M upon M square times W star squared norm. Now this is irrelevant, W star square norm, but what we can conclude is K is proportional to capital M upon M square, and this less than or equal to sign is extremely important. So what we are saying is capital M is the max of the squared norm, small m is the minimum of the dot product between input and W. So if the rate of change of the dot product between input and W is kept lower than the rate at which the squared norm of the input changes, then 100% K will remain finite. And this is the test of convergence. And once we guarantee that the convergence happens, then K will remain finite, and in finite number of iterations, our algorithm should be able to give us the correct set of values. Without this, it's very risky to proceed on these lines because deep, although they are very deep and you can have finite, but who knows, they will run for 6 months, they don't convert. That's why seeking, taking every is really important. So that's pretty much what I wanted to. Yes. Slide.
Thank you, sir. There are a couple of questions.
Sure.
The first question is there any software able to simulate the images of binocular cameras for a given 3D target?
So there is a very, yeah. So the question is for capturing binoculars for a specific target. And the same logic applies for telescope as well. So this is distant imagery, what we call. And there is a toolbox in Python. It's called as ddist, double D-I-S-T. I would recommend using that toolbox because the calibration required for the intrinsic parameters of the lens is quite different for such kind of images. And that's why if you can make use of DDIST toolbox from Python, that will help you resolve.
Thank you, sir. The next question is, can you please elaborate wavelet function selection?
So see, any wavelet has admissibility condition, which means that the mean of any wavelet function is 0, and mean is 0 statistical moment. So the first order derivative definitely exists, any wavelet function. However, in your application, what is the order of derivative that you are seeking is extremely important. If you are seeking for fifth order derivative analysis, for example, then first 5 statistical moments starting from 0th moment all the way till 4th, these are the first 5, they should vanish. When all the 5 first stat then you can make the decision. And the typical calculation is very simple. You look at length of the filter. So in case of dB, you have 8 plus 8. So 8 for low pass filter, 8 for high pass filter. So 1 minus that, 8 minus 1 is 7. So 7. So this is one way of figuring out which mother wavelet really suits your application. And I know it's a very detailed theory. It's a very dense theory. So I was very fortunate that I was able to work with Professor Gad of IIT Mumbai, and we have written a book which is titled as Multi-Rate Signal Processing, and it's published by McGraw-Hill. And we have given a very detailed treatment to this very interesting question in that book. So if you are interested, please go through chapter number 11 of that book, and you will get insights into this.
Thank you, sir. With this, we are at the end of the session, and we'll conclude the session with vote of thanks. I, Pranav Chipalkatti, on behalf of JSPM's Rajarshi Shahu College of Engineering's Department of Electronics and Telecommunication, heartily thank Dr. Aditya Abhyankar for sparing his valuable time and sharing his knowledge and experience with us. He has beautifully explored the intelligent paradigms for biomedical engineering through 3D image reconstruction. We look forward for similar future collaboration with you. Thank you, sir. Thanks a lot.
Pleasure. Thank you for the
So
opportunity.
you're requested to remain in session. We'll start with the valedictory function soon. Yeah, all the participants are requested to remain in session for the valedictory function. Thank you.
Good afternoon, sir.
Yeah. Madam, good afternoon. Faculty, HOD, principal, management, that all will become principal, not be compartments. Hello. Management will only look
Yes,
at.
sir.
Madam, this will start.
Yes, sir. Yes.
जैसे मुझे बताओ ये देखो वो देखो
हेलो
हाँ क्या हो रहा है
सर इको आ रहा है आपका सर का आवाज आ रहा है बाहर से
हाँ मैं बाहर
नमस्ते आदित्य
सर नमस्ते आदित्य कैसे लेक्चर हो गया
सर
बाहर आ जी
सर नमस्ते थैंक्स फॉर ज्वाइनिंग आदित्य
No, my pleasure. I hope participants liked it.
Must be, yes, it must be. I have 100% faith. And Dr. Aditya, today there was a meeting of Academic Council of share with you the member academic institutions. All appreciated efforts taken by my faculty and our leaders.
Of course, sir. Under your able leadership,
KPIT and ISC Bangalore. Yes.
So much under your guidance.
Today,
So I'm sure.
Yeah.
Hello.
Yeah.
Madam, please start.
Okay, sir. Okay. So with such a very informative session by Dr. Aditya Abhyankar, sir, so we may now proceed to the conclusion of 2 weeks journey of FDP on AI and its application in biomedical engineering. So with the permission of dignitaries, we may now proceed to the valedictory function. I once again welcome all, and on behalf of JSPM's Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication, I extend a warm welcome to Honorable Chief Guest and eminent personality, Dr. Aditya Abhyankar, sir, Head Department of Technology, Savitribai Phule, Pune University, Dr. R.K. Jain, Director, RSCOE, Dr. S.C. Patil, Dean, R&D, Dr. B.D. Sadhav, HOD ENTC, heads of various departments, participants, and my colleagues. May I now request Dr. B.D. Sadhav, HOD ENTC and co-convener of this FDP to propose the closing remark of the FDP. Over to you, sir.
And all, am I audible, madam?
Yes, sir.
Chief guest and speaker, Dr. Aditya Abhyankar, sir. Technology and Chairman, Board of Studies, IT, Savitribai Phule, Pune University. Dr. R.K. Jain, sir. Vice Principal, Deans, Heads, Professors, participants, ladies and gentlemen. Warm welcome for this valedictory ceremony of 2 weeks FDP on AI and its application in biomedical engineering. For kind this FDP for the 2 times and 15 days. Now total 72 sessions were conducted for the in this FDP. They shared their expertises in the application, biomedical application, and they share their these biomedical applications. Really, thanks to the all expert participants are registered and attended these sessions. Thanks to participants also, and it will help in their future careers and their involvement in this particular AI and applications. I'm sure that this FTP will help for the researchers, faculty members, students for their futures and their applications for the careers. Now, this is not end. Definitely we'll conduct such workshop under this flagship of the RSCOE in future, and we'll meet personally in future to interact ourselves in our particular FDPs and future CTPs. So once again, thanks to the Aditya sir, my principal Dr. R.K. Jain sir, management for supporting us for conducting such a wonderful FDPs for the 2 times in this pandemic situation also. So thank you very much. Good luck to the all participants and thanks for their kind supports. Thank you very much, sir. Over to Kulkarni madam.
Yeah, thank you very much, sir, for that closing remark and motivating for the faculty members. So thank you, sir. This event can be successful when the participants give their valuable feedback so that we can improve ourselves in the future coming workshops. So I hope that all your expectations are fulfilled through this FDP program. So may I now request few participants to share their views. First of all, I would like to request Professor Mahendra Kumar from DSC Bengaluru, Karnataka to express his views regarding the FDP. Over to you, sir.
Oh, thank you, madam. I think I'm audible.
Yes, sir, you're audible.
Okay, madam. Thank you, the organizer and TEL for sponsoring this FDP. And this entire 15 days FDP, that is 2-week FDP, was very informative. We got a lot of branches of application of the AI and certain part of the ML in the biomedical science or and other aspects. This gave us a lot of input to us, starting from the sessions. They started with a AI application with the a disease diagnosis, then biomedical engineering, then they had certain hands-on session to demonstrate the Python. Then they had a responsible AI for the healthcare diagnosis. Then the third day they started with EMG signal, then e-care, e-healthcare application, biomedical applications. The fourth day, they're like early invention of the diagnosis, invasive for the COVID-related data sets they demonstrated, and then AI hardware, then disease prediction with the deep learning. See, these are all part of the integral part of the AI, ML, and the deep learning we could be able to learn. And again, the fifth day, they have started with the real world data sets with certain examples. And then again, the medical imaging analysis and various image processing they demonstrated, and they shown the things. See, then again, the classification detection, then they started with giving a certain IP Act, the Intellectual Property Act, and those information. And then they have taken up the how you can take up the paper writing and paper publication, important information about the journals, how they can write in various topics for the funding authority. All this we got. This session was very informative for all the research scholars, even lecturers who are intention to have the PhDs in future also. He gave a very elaborate information. What is the meaning of writing a technical writing with respect to the publications? Then where you have to choose the publishers, how to find out the good papers, and which are the good journals, and to identify the various technical information. Then what are the funding process? Everything was there, and almost all the authors, those who presented here, they had given a good things. Then started with the machine learning identification. Then they have taken the certain research opportunities of the biomedical imaging, madam by Dr. Swati, also very was informative. Then linear classification, then Internet of Medical Things, then AI detection, then computer-aided medical images, then predictions of the brain seizure, then chromosome analysis, then AI computer vision, research opportunities in the various research funded for the biomedical images and biomedical engineering. So today's session, that was the first afternoon session, that AI application biomedical was by Dr. Aditya, was also very excellent. See, I will thank all the organizing team, principal R.K. Jain sir, then Kulkarni madam, and there again Shraddha madam, Shilpa madam, Swati, and who are all in the team. I can't leave anybody over here. Every team was there. In fact, this is my second session. Earlier, I had attended that is Smart City IoT session for 5 days FDP. That was also excellent. So that's why I choose again with the Atal portal, the same institution RSCOE. Because they collaborated the very good speakers, and with having high knowledge of the area in everywhere. In the last session also, we had good speakers who gave best knowledge. This 2 weeks FDP, that is also gave a very excellent information to us. And I request organizers, we need some of the follow-up session, because I hope by attending this much only, we can't enhance our research collaboration knowledge, anything. So we need, you make it platform so that with all the presenters, so that we can have certain follow-up sessions, so that we can get more knowledge based on our own interest of application, because we almost give around 20 type of applications we could be able to find out in last 15 days. That's what I will conclude my feedback about these things. It was excellent. I am thankful to all the organizing team, that organizing college and funding authority, and all the things. Because of this pandemic, we will be able to connect the whole globe. So Vasudhaiva Kutumbakam concept, because Atal has given such an platform that they made it this virtual environment so that we can connect with any part of the globe or any part of India. So this was very excellent sessions we had. Thank you. Thank you, madam.
Yeah. Thank you very much, sir, for your very nice feedback, and we'll really try to inculcate the things what you told. So we also were happy that you had attended our previous workshop also.
Yeah, yes, ma'am.
Yeah. Thank you, sir.
Thank you.
Yeah. May I now request Professor Anurag Verma from NIET Uttar Pradesh to express his views. Over to you, sir.
Thank you, madam, for inviting me for the back. Good afternoon to all dignitaries, participants, and I would like to thank the organizers of the FDP for such a variety of lectures, variety of areas in research field, providing such a excellent speakers, and I am doing research in the biomedical signal processing. So I got a lot of new ideas and the future directions from this FDP. This FDP cleared some of, or rather say, a lot of my doubts also, and it helped me advance my research to the next level. So thanks organizers for such a wonderful FDP. Thank you.
Thank you, sir. Now I request Dr. Ganesh Kumar from Christ, Karnataka to share his views regarding the FDP. Over to you, sir.
Ma'am, am I audible?
Yes, sir, you're audible.
Yeah, okay, fine. Respected dignitaries, industry experts, and dear faculty members, good afternoon to one and all connected in this ACT-sponsored 2 weeks online FDP on artificial intelligence and its applications in biomedical engineering. This is Dr. Ganesh Kumar, Associate Professor in Department of Computer Science and Engineering, Christ Redeemed to be University, Bangalore. First and foremost, I would like to thank the coordinator of this FDP and the event organizers from the Department of ENT for providing me an opportunity to share my understandings in this forum. The 2 weeks online FDP started on a good note, having the chief guest and the keynote speaker, Professor Rajesh, who presented on the intervention of AI in disease diagnosis and prognosis. Then we had Professor Schwartz, who prettily explained about a bird's eye view from the prospective researchers from the biomedical engineering perspective. On day 2, we had Mr. Atul, I think, highlighted the main features of national education policy. In fact, the NUP is expected to bring about several major reforms in future education in India. And in almost many STTPs and FDPs, we witness experts and senior professors deliberate on this topic. Fine. Thereafter, we had technical sessions on analysis of ECC signals, followed by deliberations on biomedical image processing, chromosome analysis, and e-healthcare, an insight on earlier and non-invasive COVID-19 diagnosis. Okay. Then we had continued with discussions on disease prediction using deep learning, clustering techniques, on real-world data set and binary genetic algorithm. During the second week, the discussions had continued on advanced AI technologies for improvising healthcare with the case studies and medical images. We had also a good session on SVM, linear classification, computer-aided analysis of medical images. So overall, it is understood that the FDP was well planned and progressed meticulously. The objective of any FDP is to impart and share the quality technical education in fostering the research, innovation, and entrepreneurship through the training in various emerging areas. And I strongly believe this 2 weeks FTP has fulfilled and met the expectations of all the participants. And a big kudos to the organizers and the Department of ENT. Once again, I thank you for the opportunity provided, and thank you all.
Thank you very much, sir, for your feedback. I request Dr. Anjana Goen from Rustomji Institute of Technology, Madhya Pradesh, to share her views. Over to you, ma'am.
Yeah. Very good morning to all the dignitaries, organizers, and participants like me. I, Dr. Anjana Goen, found my privilege that I have been given an opportunity to share my views and feedback on 2-week FDP on artificial intelligence and its application in biomedical engineering, organized by JSPM's Rajarshi College of Engineering, Pune. Since the speakers before me have already shared lots of things about the sessions, I would only say that all the sessions were very useful and interactive. Previously, the hand-on sessions were really good. I enjoyed all the sessions. It was wonderful to get associated with so many professors and experts. Actually, this is my second FTP in Rajarshi College of Engineering. I did my first FTP also. And this FTP has been organized very well planned and well organized. I would like to associate with such FTPs of this institute again in future. Actually, I had my research in biomedical field. I have done my research in real data, EMG signals, electromyogram signals, and diagnosis and prognosis of EMG signals. Since in this session, I learned about the real data. The professors worked on the real data and the analysis and prognosis and analysis of the disease. So I found those sessions very useful. The topics were the machine learning and deep learning they taught about. That was very wonderful. I thank the organizers for organizing such a wonderful FDP. And thank you all very much. Thank you, ma'am. Thank you, sir. Thank you, sir, everyone. Hello?
Thank you very much, ma'am. Yeah, we are very happy to see that you have also attended our previous program also. So we would like to always be in touch with you all. So for the further workshops in our college. So,
okay, ma'am, sure.
Yeah. Thank you, sir. I would like to request Dr. Ravindra from Indira Gandhi Delhi Technical University for Women to share his views regarding the FDP. Over to you, sir.
Thank you, madam. Is my voice audible, madam?
Yes, sir, you are audible, sir.
Yes. I am Dr. Ravinder M., working as Assistant Professor in Department of Computer Science and Engineering at Indira Gandhi Delhi Technical University for Women, Delhi. First of all, I would like to thank all the organizing committee members of the AICTE sponsored 2-week online FDP on artificial intelligence and its applications in biomedical engineering for conducting such a useful and informative FDP. Recently, I have developed interest towards medical image processing, and by attending this FDP, I got the fundamentals related to medical image processing and as well as some research directions. All the resource persons were very good, and I would like to thank all the resource persons for sharing their knowledge. And I would like to congratulate the organizing committee members on successful completion of this FDP. Finally, I would like to thank the organizing committee members for giving me an opportunity for attending such a useful FDP and giving me an opportunity to share my feedback. Thank you all.
Hello.
Yes, ma'am, you're audible.
Yeah, thank you. Yeah, thank you, sir, for that valuable feedback. So we may further proceed. Dr. R.K. Jain, sir, Director RSUE, for his forever support and presence is always a moral boost for us. So his leadership has provided an atmosphere to continuously update ourselves with the training technology. So may I now request Dr. R.K. Jain, sir, to address the participants. Over to you, sir.
Thank you, Madam Kulkarni, and thank you very much for inviting me. I hope I'm audible.
Yes, sir.
Madam?
Yes, sir, you're audible, sir.
And Dr. Aditya Abhyankar, Chief Guest of this valedictory function, Head of the Department, Dr. B.D. Jadhav, Madam Kulkarni, and Dr. Saleja Patil, all the participants. I welcome all of you for this valedictory function. And really, it is the end of the second FDP, which we conducted on this topic of biomedical and then its applications. I want to inform most of you are already attending second time. I'll not take much of the time to inform about the institution, but certainly it's my duty to inform you why we are conducting these FDPs number one, and why we call person like that, Dr. Aditya Abhyankar, to present in front of you. I'll only talk only these two issues. Friends, things are changing, but technology is changing a lot. Teacher is expected to fulfill the need of Industry 4.0. Industry 4.0 is nothing but it's now a lot of computerization is coming, lot of interface of machines and man is coming. How to fulfill that? For that, every teacher need to learn new things. He has to unlearn the old concept. Maybe he has to relearn few things, and then learning, relearning, unlearning, this phase will be continue. And we firmly believe that if we can train one faculty, then single trained faculty, good faculty, transform many lives in future in terms of students. So with this intention, we have started applying to the authorities for FDPs, STTPs, and fresher courses. And I want to inform my guest, Dr. Aditya. Sir, we got 4 FDP, STTP sanctioned from EICT and IST. And because of this pandemic, since it was remotely to be conducted, we could conduct this in 3 times. So there are 12 FDPs to be conducted. And with the intention of every FDP will be training many teachers, and teacher in turn is getting trained and will be helping the students. That was the intention. With this intention, we started doing. And I'm very happy that inauguration of the FDP one by Dr. Gache, who is one of the very, big name in the industry, in the institute or maybe industry, from the Savitribai Phule University for the research in biotech. And again, conclusion of this FDP through the hands of Dr. Aditya Abhyankar, another researcher, young faculty, and maybe role models for all the young faculty members. So my point is that why we call person like Aditya or maybe Dr. Gache? Friends, I request this person to join us. Simple reason is that their wide data, their CV, we can say, is itself is a motivating for all of us how we can develop in future, how a teacher can be transforming his life as a teacher, how a teacher is helping first himself, then to the students, and then ultimately to the institutions and to the society. So these two chief guests, Mr. Dr. Gache and Dr. Aditya, they were the examples for everybody. I hope that and there are many other researchers who spoke during this. I hope that every faculty will be taking, will get connected in future with these researchers and work further for the technology and for new things. I really think that there was very good suggestion from Dr. Mahindra. It should not be the end of the learning. I fully agree with you, Dr. Mahindra, and I ensure that there will be one track in the institutions where people are working on the biotechnology, and they will make a group, and then all the participants, those who were there in this workshop and last two workshops, they will be joining together and they will be working and helping each other. With these words, once again, I thank everybody for joining. Many of you have joined second time. Really, it shows little confidence in me that the journey which we have started is really comfortable. That's why you people are joining second time. I assure you, future also we conduct such type of workshops and programs so that we'll try to benefit our faculty. Those faculty will try to benefit our students, and ultimately a good generation of the students will be coming out from the institutions. They will be helping the society, and we all will be comfortable and safe. With this, I once again thank you very much, and once again joining us. And I once again I request all the faculty members, please just once read the biodata of that Dr. Aditya Abhyankar and be motivated the work which he is doing. Even Dr. Gache, what is his profile? You know that. Please try to understand how these people can get the time to work on the research, how they can get time to work on these projects, how they are getting time to work for the students and society. Why not we can do? So with these words, please take them as a role model and work for future. Thank you very much. Once again, thank you one and all. Thanks to AICT for supporting this activity. Okay.
Thank you very much, sir.
Thank you.
Thank you, sir. So you're providing such support for arranging all such programs and motivating all the faculty for such programs. Thank you very much, sir. So we are really privileged and honored to have with us as our chief guest, a great personality, Dr. Aditya Abhyankar, sir. So may I now request Dr. Abhyankar, sir, to address the audience. Over to you, sir.
Thank you so very much. And again, it's a pleasure and honor to be part of this August gathering. It's so heartening to hear the feedback from the participants, and there are many who have joined RSCOE for the second time. The entire organizing team, hearty congratulations, and the dynamic leadership provided by Dr. Jain and the entire team. It's a fantastic effort. Congratulations. It's also a privilege to get connected to all the faculty members across the country. This pandemic has tore down all the walls between us, and so see people from so many various institutions. And in my opinion, one of the reasons FDP is to brainstorm with like-minded professors. And this is a wonderful opportunity. While doing our mundane tasks day in and day out, sometimes we forget the very art of asking interesting questions. And I would like to share the teaser, which is very close to my heart, with all the faculty members. The calcification is so subtle that sometimes we don't even understand that it has happened to us. And the art of asking questions is so much very important. We always do this exercise since I work in machine learning and we write algorithms. And my students sometimes say that, what is art of asking questions and why is it so important? Why are you stretching so much? And just to make them realize that how insensitive sometimes we go to this very art of asking interesting questions, I share one teaser with all of them. And this is again connected with machine learning. In machine learning, we write algorithms which are iterative. And we say iteration after iteration, the algorithm marches on towards the optimum solution. So there is this popular saying in English, we say march on towards your target. We never say January on, do we? So why January is the first month in our calendar? And then February is the second month, and suddenly we stumble upon some odd number of days in February. Sometimes 28, if we are leap year 29. Is it not really strange? And let's play a game. since we say March on, let March be the first month of our calendar system. And then April is the second month and May is the third month. And it continues. And as we are in the seventh month, in Sanskrit, 7 is Sapta, and we get September out of it. And 8 is Ashta, and we get October out of it. And 9 is Navam, we get November. And 10 is Dasham, and we get December out of it. And now January becomes the 11th month, and February now becomes the 12th and the last month. So it's okay to have odd number of days in the last month of the calendar, because we typically do the adjustment in the last month. Only if we start our calendar in March, it would make sense to have odd number of days in Feb. And it's all about also following the nature. In nature, the new things would start to propel in the month of March. In Indian traditional system, we call it as Vasanta Rutu. On 21st of March, typically we have equinox. So 12 hours of day and 12 hours of night. And then from that equinox, the Vasanta Rutu kind of begins. And in the olden days, in Vedic literature, you will see that that's when the start of the year used to happen, from 21st of March. If you look at many other systems, Greek calendar system, or the latest Hindu style of doing it, Buddhist style of doing it, or Japanese school, or old Chinese system, or let's forget about Chinese system in pandemic. Or if you look at the Roman calendar or Greek calendar, they all suggest starting our year by around March or April. And then the question is, if that is so, then why do we have 1st of January as the starting of the calendar? And the answer is probably known to most of us, but what is important is, have we lost this art of asking interesting questions? Calendar is so dear to our heart. The moment we get up, we are interested in figuring out what day and what date it is. And yet, not just bunch of us who are connected through this platform, but the entire universe follows this logically illogical calendar. And we start our year in Jan. It's not very strange. So let's together build this consensus of bringing back the research culture, bringing back the culture of asking interesting questions, and by virtue of doing brainstorming, because these are the opportunities for us, the professors. We are the intellectual forces of our institutes, and it's very important to challenge our wit, go out on a limb, step out of the comfort zone, ask stupid looking questions, but no question is stupid, and every question has its own sweet potential. And research, deliberations, brainstorming, these are the platforms that will give us these opportunities. And that's why such kind of activities are very important for overall growth and development of all of us, the faculty members. I once again thank the organizers for creating such a wonderful platform and inviting me to be part of this August gathering. Happy researching, happy having fun in biomedical domain. It's a field which is absolutely going to rock for next 20-25 odd years. And last but not the least, let's not forget what our megastar Amitabh Bachchan says, जब तक दवाई नहीं तब तक ढिलाई नहीं. Stay home, stay safe. Thank you so very much.
Thank you very much, sir.
Thank you very much, sir, for your kind words
Thank
and
you,
cooperation.
sir. Appreciate it, sir. Thank you.
Thank you very much, sir, for that thought-provoking and very interesting words and importance of art of asking interesting questions. Thank you very much, sir. So I take this opportunity to propose vote of thanks. I extend a very hearty vote of thanks to eminent personality, our today's chief guest, Dr. Aditya Abhyankar, Head Department of Technology, Savitribai Phule Pune University, who shared his valuable time from his busy schedule to grace the occasion as well as a speaker. Thank you very much, sir, for your thought-provoking and interesting address. So first of all, I would like to thank AICT to sponsor this faculty development program on AI and its application in biomedical. engineering for the betterment of the faculty. I would like to extend my gratitude towards JSPM Group of Institutes, Founder Secretary Honorable Dr. T.J. Sawant sir for his timely support to organize such an event successfully. I would like to take this opportunity to thank our Director, Dr. R.K. Jain sir, for his perfect logistic support and guidance for the program. I would also like to express my sincere thanks to Deputy Director, Professor A.S. Devasari, for his enthusiastic support. I'm happy to express my gratitude to Dr. B.D. Zadav, co-convener and HOD, who to always show keen interest and support in all these ways. My deep sense of gratitude to Dr. S.C. Patil, the R&D Dean and co-convener who planned this program. Last but not the least, I extend my sincere gratitude and appreciation to all the participants for their cooperation and presence, which led to the grand success of this program. Thank you very much. So before we end with this program, I would also like to announce that quiz is organized and the link for the quiz will be shared on mail. The quiz duration will be of 1 hour and it will be active till 10 p.m. today. So before we come to the conclusion and closing ceremony of this, so I would request all the dignitaries and all the participants to keep their video on to capture the glimpse of this moment. All the participants, please keep your video in the on mode. May I now request Shraddha ma'am to please capture this moment of the program. Shraddha ma'am, are you ready?
Yes, the videos are turning on. I'll click the first picture. Yeah, one more. Yeah, done. Thank you all.
Thank you, sir. Thank you, one and all.
Thank you.
Thank you, madam.
Thank you.
Thank you all.
Thank you.
So we conclude this program of today. Thank you very much, everyone. Stay safe.
Kulkarni ma'am, shall I end the meeting?
Sir, we'll just for 2 more minutes and then we'll end the meeting.